tackling worksheet 11. We'll be looking at integration mainly. So you are free to follow along as we go through these problems. So if we start with question 1, right? So let's just make some space there. So starting with question 1, you have a problem that is asking you to solve for the integral of the hyperbolic sine of x. So this was a mistake on my side, by the way. It's supposed to be hyperbolic sine of x divided by the square roots of the hyperbolic cosine of x squared minus 1. And to solve this, we have to use the rules that we know of hyperbolic functions. And by the rules, I mean, we know that the hyperbolic sine squared plus 1 is equal to the hyperbolic cosine squared of x. Okay, so this is one of the rules. I'll just try as many rules as possible. And then the other rule we know is the hyperbolic sine of x is equal to, let me just give me a minute. Please mute yourselves as you're joining in. So the hyperbolic sine of x is equal to e to the x minus e to the negative x, right? All divided by 2, right? So we have that. And for the cosine, the hyperbolic cosine of x, we have that it's equal to e to the x plus now e to the negative x over 2. And as you can see from these definitions, this therefore implies that if you look for the derivative of the hyperbolic sine, it's just equal to the hyperbolic cosine. And the same the same works the other way. So the derivative of the hyperbolic cosine is equal to sine the hyperbolic sine of x. So that is it. So now, based on these identities that I put here, what do you think we can suggest to solve this problem? Which one can we use, if any? Anyone? Just think about it. So if you look, one might be tempted to use the U substitution here, right? And the issue with the U substitution is you might find that the U substitution takes way too long to be solved. Okay, so it's always a good idea to try to simplify the original expression in such a way that you can solve the integral without having to resort to complicated substitutions. So I would suggest that we use this identity here that says that the square of the hyperbolic sine of x plus 1 is just equal to the square of the hyperbolic cosine, right? And knowing that, then the hyperbolic cosine of x minus 1 is just equal to the square of the hyperbolic sine, right? And obviously, since you have the square of the hyperbolic cosine there, under the square root sign, this just gives you the hyperbolic sine of x, right? So now you have the integral of hyperbolic sine of x over hyperbolic sine of x, which can just be simplified to be equal to 1. So now you're integrating 1 between 1 and 4. So what is that equal to? Give me the answer. I want you guys to attempt it. Just give me a minute, guys. Yes. So what is the answer, guys? Come on, don't be shy. You can type the answer in the chat box. I'll be checking the chat.
I think the answer is 3.
Okay, thank you. Yes. So the answer is 3 because when you integrate 1 dx, you just get x, right? But now this x is evaluated between the boundaries from 1 to 4, right? And now that you have that, you substitute the higher boundary, it's 4 minus 1, which is just equal to 3, right? And therefore, the answer is option E there. So, any questions here? All right, so you're free to pause me at any time during the session if you have a question. So, moving on to question 2, we have the integral of x squared minus 1 over x dx evaluated between 1 and e, right? So immediately what you can say is you can try to simplify this expression further, right? So how do you do that? Well, the way you would do that is you can divide the x squared by x, right? And then you have x that is left minus, right? Let me put the bracket there. There will be x minus the 1 divided by x, which is just 1 over x, right? This is equivalent. Now you have the difference of two functions in x, which you can just separate into two integrals, right? You can use your sum rule, I think is how you called it, of the integral now of x minus, right, the integral of 1 over x evaluated between the same boundaries. Now the integral of x is just x squared over 2, right? Plus c. So always remember the constant of integration, plus c. But now this is evaluated between e, right, and 1, minus the, what is the integral of x equal to? Can anyone suggest the answer here? Hello, anyone?
I think it's Linux plus C.
Right, thank you. So it's Linux plus C, right? So then, when you have this, you can evaluate this integral, but first evaluating the first one here. So if you evaluate the first substitution there, what you get is, right? You have to substitute in the value of x, right? The higher value first, which is e squared, right? Over 2 plus c, minus the lower value substituted in, right? Which is just 1. So it's 1 squared, which is just 1 over 2 plus c. That is subtracted from ln x plus c, right? Evaluated at first the high limit, which is just ln of e, right? It would be minus minus, so it would become plus, right? So it would become plus ln x plus c evaluated at 1, which is just ln of 1 plus c. And this is just equal to then, as you can see, the c will cancel on either sides there. Then you'll have e squared over 2 minus 1 over 2, right? Remember the c has canceled. Then you have minus ln of e. Ln of e is just 1, right? Plus c. The c from here will just become minus c plus c, which cancels again. So you have minus 1 plus ln of 1, which is just 0. So plus 0. Plus 0. And this is equal, therefore, to e to this square divided by 2 minus 1 over 2 minus 1 is just minus 3 over 2, right? Which is the final answer. So now, does this make sense to everyone? Any questions? Okay. We'll move on to the next question. So looking at the next question, we have that if we are given that dy dx is equal to, let's just go down here, make some room. So we're given that dy dx is equal to that. And we are asked if y is equal to, okay, so no, we're given that dy dx is equal to sine x cos squared x, if y is equal, and if y is equal to 0, we have that x is equal to pi over 2. And we are asked to find the value of y when x is equal to 0. Okay, so looking at this problem, what do you suggest we should do to begin solving it? Anyone? Because remember, we are given as y is equal to 0, x is equal to pi over 2, we are asked to find what is y when x is equal to 0, right? And we are given the dy over dx is equal to stat, right? So straight away, if you think about it, you can simplify this expression by just taking the dx on the right-hand side there. So this would just become dy is equal to all of this multiplied by dx, right? So you have the derivative of y is equal to sine x cos squared x dx. So therefore you can estimate what is y equal to. And if you have dy and you want to find y, what do you have to do? It's my question to you. I'll give you guys a minute to think about it. So you're given dy. Dy is a function of x. So that's the derivative of y, which is just a function of x. So if you're given that, how do you find y? So what is y equal to? In other words, what is y? What is y equal to? Knowing what is dy equal to. What is y equal to? Come on, guys. This is basics. So you have the derivative of y, and you're trying to find y. All you have to do is just implement the integral, right? I'm hoping this sort of makes sense. Trying to see if I can find an integral. Let me just insert. Right, so you're given dy, you're given the derivative of a function. To find what that function is, you just have to integrate it. Integrate its derivative. So you just integrate, right? Sine x cos squared x dx. And in your opinion, how do we solve this integral? What can we do? What can we do to solve this integral? Come on, guys, the class is very cold. There's how many of you guys in here? Let me see. All right. There's about 30 or so people in here. I'm sure one of you has an idea of what to do. So, speak up, guys. Remember, these sessions from now on, since you guys are done with all your tests, these sessions are mainly for revision purposes. So you need to be more active. So how should we solve this? Based on all the ways we can solve an integral, how should we approach this problem? Well, we have the integral of sine x cos squared x, right? The way we could solve this is by using u substitution, right? Which you guys are familiar with. So if you use u substitution, One substitution that you can possibly use is that to let u be equal to, let's say, for example, cos of x, right? If you let u equal to cos of x, I want you guys to attempt solving this and tell me what you get. Then we can discuss. So I will give you guys 5 minutes. Using this u substitution, I want you guys to attempt to solve it and then tell me what you get. All right, remember what you have to start with. You're given u is equal to cos of x. What is du equal to? Hello, guys. Anyone?
Yes.
What is, if you're using the u substitution, u is equal to cos of x. What is du equal to?
D is equal to negative sine x times dx.
Thank you. So negative sine x dx. So now that you have that, you can find what is dx. So what is dx equal to? Come on, guys. What is dx equal to?
Dx is equal to negative du over sine x.
So negative du over sine x, okay? Good. Thank you. And now that you have this, you can substitute it back into the integral. So if you do that, what do you get? If you substitute it back into the integral, you have that. You remember you let your u be equal to cos of x. So now you have u squared there. And you have dx is just equal to du, right? Du divided by, or rather negative du. So I'll just take the negative in the front here. Negative du divided by sine of x. Right? And now that you have that, you see that the sine will cancel, right? And you will be left with use the integral of u squared du, right? And obviously you remember that the integral of u squared du is just u cubed over 3 plus c. Okay, always remember the integral, the constant of integration, c. So now that you have that, going back into your original substitution, you have that this is equal to cos cubed, right? Cos cubed. Oh, so cos cubed of x divided by 3 plus c, and now that you have this, you have the value of y, which is just y, right? If you go back to the problem, it tells you that when y is equal to 0, x is equal to pi over 2. So, meaning, if you have this equality here, let me just rewrite it. If y is equal to 0, x is equal to pi over 2. So let's substitute y by 0 and x with pi over 2 and see what we get. So now, what is the cosine of pi over 2? Come on, guys. What is the cosine of pi over 2? Guys, come on.
I think it's 0.
Cosine of pi over 3 is 0, right? So therefore, if you go back to this equality there, cosine of pi over 3, pi over 2 is 0. 0 cubed is just 0 over 3, just equal to 0. So you have negative c basically is equal to 0, which just means that c is equal to 0. So now you found the value of c, right, which is 0. Meaning, if you go back to the original inequality, sorry, equality, it's not an inequality, it's an equality. If you go back to the original equality, you have now that y is just equal to cos cubed of x over 3, right? Which is helpful because then we can evaluate the value of y when x is equal to 0. So now if we substitute, right, so if we write when x is equal to 0, right, we have, what do we have? When x is equal to 0, we have that y is therefore equal to cos of 0 cubed divided by 3. And what is that equal to? Guys, come on.
Negative 1 all over 3.
Exactly. So negative, oh, there's no c here, by the way, sorry. So it's negative 1 over 3, which is your final answer. So the answer should be E. Any questions there? Okay, so moving on, we have that if the integral of 2kx minus x squared dx is equal to 18, and that is evaluated between 0 and k, what is the value of k? So off the top of your head, you can already think that what you have to do here is first integrate. So you integrate the left-hand side. So if you integrate 2kx, knowing that k is a constant, right? You have, right? Let's put it in brackets. You have that is equal to just 2kx squared divided by 2, right? Minus x squared, the integral of x squared is just x cubed divided by 3, right? And this is evaluated between k and 0, or rather between 0 and k. And when you substitute in the values for x, you get that for the highest limit, which is k, you have that this is just equal to, obviously the 2 will cancel here. So this is just equal to k times k squared, which is k cubed, right? Minus k cubed over 3, right? And all of this is minus 2k times 0, sorry, rather k times 0, which is just 0, minus 0 cubed over 3, which is just 0. So this whole thing is 0. And that should be equal to 18. Right? So now, going to the next step, you can eliminate that 0, and you can find that if you do k cubed minus k over 3, this will just give you 2k cubed, right? 2k cubed over 3, right, is equal to 18. And now that you have that, you can solve for k. So I want you guys to tell me, what is k equal to?
K is equal to 3.
K is equal to 3, right? Thank you. So that is it for this problem. So the answer should be option D. Okay, so if you look at the next one, you are given, sorry, could you just give me a minute? I'll be back.
DJ.
All right, sorry about that. So looking at question 5, you see that they tell you that if f is a linear function and it's such that 0 is less than a, which is less than b, right? Evaluates the integral from a to b of the second derivative of f of x, right? So now this question is a little bit more tricky than the others. So what is a linear function first? They say f is a linear function. What's the definition of a linear function? What's the definition of a linear function?
Linear function.
Sorry, go ahead.
I think it's have a power of 1. Exponent 1.
It's a function of an order, yes, or order of 1, meaning a function with the general form mx plus c. I believe is how you guys learned it. So let's just write, yeah, we can leave it like that. So a function of the general form mx plus c, where m is the slope, right? Remember, m is the slope, and then I believe it says that c is the intercept, right? So then, if you have that f of x has this general form, right? What do you think is the derivative of f equal to?
It is equals to m.
Right. Thank you. So if the derivative of f of x is equal to m, what do you think the second derivative of x is equal to? So the first derivative of x is equal to m. What's the second derivative of f of x? Sorry, not f, not x.
I think it will be 0.
Right, so
What
it
is
would be 0. Right? So basically what they are asking you to do here is to integrate 0 dx, right, between a and b. And what do you think this is equal to? Just think about it and tell me.
I think it will be 0 as well.
Can you explain for those who might not understand where the 0 come from?
Okay, it will be 0 squared all over 2. Then 0 squared is 0.
Sorry. Where does the square come from? Because if you look at this, you have the integral of 0 evaluated between a and b. And remember what's the integral means. It means what function do you need to derive to get 0? So what do you need? What can you derive to get 0?
Any constant.
Any constants, right? So thank you. So if you were to look for the integral of 0, meaning the function that you would need to derive to get 0, it would just be equal to any constant. Let's call that constant b. So just so we don't confuse the c's there. So let's call it b. So it will be equal to any constant b that can be derived to give you 0. And this constant would be evaluated between b and a, right? So now, if you evaluate this constant between b and a, remember there's no term in x. Usually what you do is you replace the values of the boundaries wherever you see x in the function, but there's no term in x. So when you try to replace the b, let's call it t, so it doesn't confuse. So when you try to replace b, the upper limit b into this, it will just stay d, right? And when you try to replace the lower limit a into that, it's just going to stay d again. So it will basically be d minus t, the constants minus the same constant, which is just equal to 0. So hopefully this makes sense. Meaning the answer here is equal to 0. Okay. So now moving on to the next question.
So why is the answer E?
Sorry?
Why
E
do you say the
meaning
answer is
0.
0?
It's 0. I just explained it here. So we said that f of x is a linear function. That's what we told in the problem. And a linear function has the general form mx plus c. M and c are constants, right? So when you take the first derivative of f of x as a linear function, you get m. The second derivative of a constant is just 0. So this question here is basically asking you to find the integral evaluated between a and b of 0 dx, right? And the integral of 0 is just a constant. We can call that constant anything. I decided to call it d. And that constant d has to be evaluated between the bounds that are given, a and b. But now remember that when you actually evaluate the function between boundaries, all you do is just substitute wherever you see x with the upper boundary, and then you subtract that by the same function, but now substituted in you substitute the x by with a, right? So, but we don't have any x here. We just have a constant. So when you substitute the upper boundary, it just comes back as d, the constant. And when you substitute the the lower boundary, it just comes back as the constant again. So you basically have the same constant subtracted from the same constant. So, and that gives you 0, which is why the answer is 0. Hopefully this makes sense. Feel free to stop me if you don't understand again. So moving on, for the sake of time, we're looking now at if f of x is given to us as the integral evaluated between 0 and x of the square root of t cubed plus 1 dt, we are asked to find what is the value of f prime substituted by 2 wherever you see x, right? So f prime of 2. Now we have f of x. So the first thing we would need to do is just find f prime of x, right? Which is just the derivative of f of x, right? So this would just be equal to d derivative of the integral all over dx, right? So let me just put this, or rather, let me just do this like this. So it's d over dx of the entire integral. So the derivative of the integral. And remember, the derivative of the integral is just the function that is being integrated. So the derivative of this integral is just equal to that. But now this is evaluated between the boundaries given from 0 to x, right? And if you substitute in the upper boundary, you will get the square root of x cubed plus 1 minus the square root of 0 cubed plus 1, which is just the square root of 1, right? So hopefully this makes sense. And when you have that, it just becomes the square root of x cubed plus 1 minus 1. Please mute yourself. You cannot ask me a question. Okay, so then when you get this, you are asked to find now this derivative evaluated at 2. So you just substitute into the function that you just got 2. So you're looking for f prime evaluated at 2, which will just be equal. X substituted by 2 is just 2 cubed plus 1 minus 1, right? And 2 cubed is 8 plus 1, which is 9. The square root of 9 is 3. 3 minus 1, which is just equal to 2. Okay, so the answer is A here. Any questions here? No. Okay. So I want you guys to attempt 7 and 8 as well. So I want you to attempt 7 and 8 and see what you get. Now 7 and 8 are a bit a little bit more challenging, but they require you to think. Like for example, for 7, they're asking you for the integral evaluated between 1 and 4 of the absolute value of x minus 3. So the first thing that you need to do is first study the sign of the absolute value of x minus 3 between 1 and 4. So you have to first evaluate this absolute value as a piecewise function, right, which you guys have done. You evaluate x minus 3, the absolute value of x minus 3 as a piecewise function between 1 and 4, and then you see how the function changes signs. And then basically what you will get is two integrals, right? The sum of two integrals that you have to evaluate and then get one of these values as the answer. For 8, you have the limit as h tends to 0 of the integral of 1 evaluated between 1 and 1 plus h of the square root of x to the 5 dx over h. And they're asking you to see if this limit exists. So the first thing you need to do is to evaluate the integral at the top there. Then, as soon as you evaluate this integral and you substitute in the values of the boundaries, you will see that at the top you will get you'll only be left with expressions in in h, right? So you'll have at the top in the numerator expressions in h divided by h, right? And then you use your limits, your rules for limits. You just see if it gives you 0 over 0. Chances are it's going to give you 0 over 0, and then you will have to see if you can use the different methods to solve that limit. Basically, more likely L'Hopital's rule, right? So that is what I want you guys to do for the rest of the session. I will have to end it here because I just got an emergency that I have to attend to. So thank you